Good evening, my students. Welcome to the session number 3 of Gauss's law. In the last lecture, we have seen how to find field using Gauss's law. Today's session is going to be a very interesting session because you're going to see some properties of conductors which probably you wouldn't have heard of and which is normally not taught in the regular coaching. So get ready with me, guys. Shreyas, your master teacher for physics at Vedantu. How is everyone? Hi Enthuse FC, hi Abhishek, hi Kirito, hi Shrinu, hi Chandan, hi Mininarthi, hello Shreyas Kapri, hi Priyanka, hello Ankit. Welcome everyone. How is everyone? Nice to see all of you and take care, guys. Yes, we Enthuse FC, I have heard you, and don't worry, I'll check back and in the admin account and I'll definitely unblock your other accounts. Don't worry about it. All right, I know you're a regular enthusiast, so let's get going. Hello Vikram, hello Stravika, hello Thunder, hi everyone, hi Wigzy, yes, Wigzy, nice name, thank you so much Wigzy, love you too Chandan Beta. And guys, if you want to know more about me, definitely you can follow me on my Instagram handle, that's Shreyas_Vedantu. So I keep posting a lot of things over there. And before we begin the session, do not forget to hit the like button and do not forget to hit the subscribe button, because the only time when you subscribe and like our videos, that's the only time when YouTube will recommend our videos and you will not miss out on all the important updates or all the important lectures that we conduct. So what is this series called? This is called as Pathfinder series. Who is this series for? This is for the 11th to 12th moving students right now who are in the 12th standard. What is this for? This is a long-term batch. So Pathfinder series is a long-term batch and we started with electrostatics. The playlist of electrostatics is there inside our channel. Then we'll go to current electricity, capacitors, magnetism, optics, EMI, AC, modern physics, semiconductors. All these topics will be covered in this series. So usually you will have at least 2 classes, sometimes 3 classes, unless and until there is some kind of exam. That time you will have maybe a class less or something like that. So welcome aboard. Thank you so much Thunder for loving my teaching, but Thunder, I am right now on the English channel, so I'll have to teach in English, bacha. All right, so hi Chandan, thank you so much for loving my hairstyle. And otherwise Thunder, I hope you are in English medium, and let me tell you Thunder, what is the benefit of learning in English? It will help you later on at later stages of life, and you will remember this channel for that, because when you go to companies, when you go to foreign countries, or when you go to higher education in India or even abroad, you will have to converse in English. The teachers will also teach in English. Obviously when you go to IT, teachers are not going to teach you in Hindi, so it's better to get used to this style of teaching. All right, so no problem Munna bhai, it's okay, you can watch the recording, no problem. So we Enthuse FC, the thing is I have little bit of fever, my temperature is little bit high, and hi Catsterin, after a long time I'm seeing. Hello, yes Abhishek, even in interviews. Yes Heyman, thank you so much. So that's why I'm not feeling that well. I was planning of cancelling the class, but then I thought, no, I think I can gather up all the courage, and thanks to your love and support I'm here, guys. Otherwise, trust me, I would be resting on the bed. So I'm not sure if I'll be able to take the class tomorrow, so I'll try to take the class tomorrow, but worst case, if I'm not at all well in the morning, then maybe I might have to cancel the class tomorrow, which is the Zero to Hero series. Now I have a very interesting surprise for all of you. Okay, so all the surprise, yes, some of you already know it. So the surprise is basically called as VIP, which is Vedantu Improvement Promise. Now if you go to the Vedantu website, you will see this promise. Now what is this promise basically? If you go to the Vedantu website, you will see something called as the VIP. We promise academic progress. Now this is happening for the first time in our country, probably, especially in coaching, where we guarantee you results, where we tell you your improvement. We tell you that you are going to improve this much by conducting benchmark tests, by telling you what is the pattern you should follow, what are your strengths, what are your weaknesses, and we guarantee you, if you follow these set of rules, for sure you are going to improve by this much. That is what VIP treatment is all about. No coaching institute gives this, but we are giving it on the website. You will see all the important videos. So just go to vedantu.com, okay, and just click on VIP over here. Just click on VIP and you will see all the details for 11th class, for 12th class, for freshers, for repeaters, everyone. All right, we will set your expectations right and we'll guarantee you that you meet those expectations. So all the details of how we train kids, how we ensure this is mentioned on this. So I will tell you more about it later on. So remember, when you are a pro user, so if you are a part of the pro subscription, you also get this VIP benefit. So those of you who are considering offline versus online, online versus online, so let me tell you, this VIP feature is a killer feature, because that will enable you, that it will give you that confidence. It will enable you to progress, all right, without having to worry about many things, because we will give you a defined path. So guys, definitely you should check this program out, and you should definitely consider joining in the pro subscription. Okay, no problem. Glad you guys have watched all the replays. Yes, Chandan, I just told I'm not feeling well, but I'm still here for somehow gathered all the courage to be here. Thank you, Srinu, and thank you everyone for all your kind wishes and all your lovely wishes. So let's begin with our class today. So I might be a little bit low on energy, but your energy, your joy should not be less. And please show your love and support to all the teachers at Enthuse and Vedantu by smashing that like button in case you haven't done it yet. All right. So the first property which you should know is this. Charges on a conductor are always on the surface of a conductor. Now there is a very simple way to explain this. See, positive and positive do not like each other. All right. So if imagine you have a Pandu, okay, who does not like another Pandu, what will these two Pandus do? They will try to move away from each other. Correct? Now imagine there is a room full of Pandus. There is a room full of Pandus. None of them like each other. All of them hate each other. What do you think will these Pandus do? Will they accumulate over here? Will they gather over here? No, right? They don't like each other. So all of them will go to one corner. They will be away. So that's why when you charge something, you will see all the charges go on the extreme periphery. Very easy way to understand this. So this is the first property. You can write it down. I know you will get the slides also as a PDF, but when you write and when you draw, I think it will create an impression in your head. Yep. So is NCERT enough for chemistry till JEE Advanced? Well, Ankit, no. But also I will definitely help you out in the comment section. Don't worry, I'll reply to all the comments. Now, the next important property. Hariharan, I tried registering for the vaccine, but unfortunately the website crashed. So none of the people are able to register, but I'm trying my best. I'll definitely register for the vaccine, and you should also encourage all your family members, your brothers, sisters, friends who are above 18 to take the vaccine. Do not worry about the side effects. The side effects will be there, but it will be negligible, and for most of the people it will not be shown. It's better to get the vaccine and have those mild reactions than suffer from COVID. I hope you agree with this point. Okay. Next is, if there is a cavity inside, then the charges will lie on the surface of the conductor and not in the cavity. This is also very simple. This is a hollow object. There is some cavity. Cavity means, think of it like this. Imagine, guys, there is a room, okay, and there is a place where, let's say, there is a pond. Okay, no Pandu is allowed in the pond. You cannot enter inside. So what will all these Pandus do? Again, they hate each other. Whether this pond is there or not there, it doesn't matter. All these Pandus hate each other. They will anyways run towards the end because they don't like each other. So these charges will always run towards the end. They will not gather near that pond. So that pond or that empty space, think of it like a no dead man's zone. No person should go there. No charges should be there because that is vacuum or air. So the charges can only flow around inside the solid part of the conductor. These charges will repel and they'll only gather on the complete outer surface, not on this surface. Understand? This surface does not have any charge. So that's what is said. So there is no charge on the cavity. Okay, great. Yes, donut is an example. Correct. Yes. Aniket, every vaccine has side effects. When you are a kid, you would have taken polio vaccine. Even polio vaccine has a side effect. Not all people get it. Few people show. They might get some small fever, or they might show some pain in the body or something like that. So when you are a kid, you have already encountered that, just that you don't remember it. So just like polio vaccine, measles vaccine, every vaccine will have something. Even crocin, a lot of people don't know this. Even crocin, paracetamol has side effects. Any tablet you take has side effects. So people are foolish. A lot of people around there are creating rumors. Oh my God, people are going to die if you take this vaccine. You are going to suffer with this disease. You are going to get that, this, etc. These are all rumors. Don't believe this. You are all educated people. You are all preparing for the toughest exam, preparing for IITs. Some of you are going to become doctors. So you guys should be the front runners. Educate others that don't worry, everything will be all right. Yep, correcto. Let's get going to the next one. Now, if there is a charge inside a cavity, then things are different. Please understand. There is a charge inside that empty space. Now, think of this charge, all right, like a hot pandu, this positive, all right. So imagine this is a pond, or let's say there is a mermaid. Let's say there is a mermaid. Okay, this is the mermaid. I don't know. Okay, this is the mermaid in that pond. This is, yes. So what will happen? This is the pond, guys, and this is the room. Okay, this is the boundary. What will happen? All the pandus will gather to see the mermaid, correct? So all the pandus are going to gather. Oh my God, such a beautiful mermaid. So they are all going to gather here. Now, where will these pandus come from? They would have ditched somebody and they would have come to see the mermaid. I hope this is clear, guys. So they would have ditched somebody to come and see the mermaid in that pond. Is that clear? Yes. So guys, the same thing happens. When there is a positive charge, what will happen is these negative charges will gather here. They'll be like, oh, positive charge is calling us. They'll get attracted by it. Remember, the positive is not on the surface, it's inside that cavity. So where will these negative charges come from? They would have traveled from the outside. So there will be an equal amount of positive charge. So this will be an equal amount of positive charge. So as many negatives, that many positives, because each negative charge would have traveled. I hope this is making sense. So each negative charge would have ditched the positive nucleus, and that's why you will get negative charge induced on the surface of the cavity and positive charge induced on the outer surface of the cavity. If this was not a positive charge, this was a negative charge. So if this black one is a negative charge, then exactly opposite signs would be there. So there would be positive charges gathered over here, and the outer periphery would have negative charges. Is that clear? Yes, all the pandus have ditched their champas. Yes, correct, Abhishek. Yes. I hope this is clear. Okay, so Arman, I'm so sorry to hear that, but you know, like I said, side effects will be there, but it is 1 in a million. I know statistics tells you something and feelings are somewhere else. Even one life matters, I know that, but I'm really sad about it. All right. So let's get going to the next property. If there is a charge outside that thing, that means this is a room, there is a pond, and there is a beautiful champa over here. Okay, so champa is here. So what will happen, guys? The pandus who are there here, they will all gather to see the champa, beautiful champa, correct? They would have ditched those other champas, all right? So guys, what is going to happen is, the moment you have a positive charge, you're going to see negative charges getting accumulated here, and an equal number. So 1, 2, 3, 4, 5, 6. So equal number of positive charges again on the periphery. 1, 2, 3, 4, 5, 6. So these electrons have traveled like this. Remember, the charges which are induced, all right, the charges which are induced are on outer surface only. Keep this in mind. So they are still on the outer surface, it's not on the cavity. Please keep that in mind. Yes, there will be a charge separation. Sanjay, sorry bacha, I will not teach fast because this is Pathfinder series. Flash series was somewhere between one shot and the long term batch. So understand, we are teaching all kinds of students out here. So I need to consider an average student and teach. So I'm not choosing the lowest student or the most a student who is not even paying attention or something like that. So I am considering an average student with average attention span should be able to understand this. But remember, in Vedantu Pro subscription we have all kinds of batches. We have the we have the topper batch, we have the normal batch. So if you want to learn really fast, I am already teaching in the topper batch. Okay. Yes, Aditya Verma, I did. Okay, so let's see a question which is coming up on your screen, and yes, that would be called as induction. Correct, Vikram? Yes. Consider a neutral conducting sphere. A positive point charge is placed outside the sphere. A positive charge is placed outside the sphere. The net charge on the sphere is, come on, answer this. Sanjay, I'll need to teach the properties at least, na bacha. I cannot skip the properties, and through the properties only you will understand the concepts. See, if I directly come to this, then if you don't know any theory, then you will not understand this problem. I understand what you're saying, Sanjay, you want more of problems. So that's why we have the pro subscription where we conduct lots of problems, alright? So I understand how to teach balance between theory and problems, both. Okay, so that's why I'm keeping a mix of both. I cannot completely ignore theory nor completely ignore the problems part. Thank you, Khushbu, so much. Okay, so by the way, Sanjay, we are also going to have special problem solving sessions also, just problem solving sessions. Yes, we are going to have lots of problem solving sessions, like we have Killer Phi, we have Zero to Hero series, so many other problem solving sessions are there. Okay, so guys, think about this. What is the answer? So first of all, consider a neutral conducting sphere. Come on, think. Some of you are saying D, some of you are saying B, some of you are saying 0. So if you have a positive charge here, then you will see negatives getting accumulated here and equal amount of positives getting accumulated here. So you are seeing separation of charges. These are basically induced charges, and whatever electrons have come, they have ditched some protons only and come. The total charge is still 0. So understand, the total charge is still 0, because if you count the negatives and count the positives, it is still going to be the same. Good evening, Rushada, welcome aboard. Yes, epic blunder. Okay, I hope you guys understood this. So none of the other options are correct. Okay, so let's get going to the next question coming up on your screen. Yes, that is 0, guys. Correcto. Now let's see whether we can do this. Now here we go. Draw the possible charges on all the surfaces of this neutral conductor with a cavity, and there are 2 point charges. Look at this, there is one cavity here and there is a point charge somewhere towards the right side, and outside this conductor there is another negative charge over here. So first of all, let's try to think about this. How will the charges behave? So guys, first of all, I feel because of this positive charge, this cavity surface will have negative induced charge. All the electrons will be attracted by the positive charge. So I feel there should be negative charges here, but since the positive charge is more towards your right side than the left side, so electrons will accumulate more over there. I hope you see that. Yes, so basically understand, the positive charge is more towards the right, so more Pandus will gather here to see the mermaid. Think of it that way. So there will be more negative charges here and less of negative charges over here. So that's how the distribution will look like, those minus charges. Now where will the negative charges come from? They would have ditched the positive charges. So obviously you will have positive on the outer periphery. So you will have positive on the outer periphery. But be careful, they can't be distributed uniformly because there is a negative charge here. So this negative charge will attract those positive charges more over here. Understand? So there will be more of attraction here and there will be less of positive charges on this side. So positive charges will get pulled by the negative charge. That's how I think the diagram is going to look like. Is that clear? Thank you, Rushuda, Mansuri. Thank you so much. Yes, Jatin, you will definitely face problem in certain parts. So Jatin, my advice is please watch the Flash series of SHM. And if you are already in pro subscription, you will find a lot of micro courses by teachers like me on SHM, rotation, etc. So I'm going to tell you more about micro courses in a bit. Yes, so guys, that's the answer. Correcto. So like I was saying, somebody was asking, sir, yeah, is there a way to learn all the 11th standard topics which I have skipped or I am not comfortable with? So that's what micro courses is all about, guys. In micro courses, you can study any 11th or 12th standard topic, not just topic like ray optics, wave optics, EMI, wave optics, polarization, nothing, not just that. We can also study from an exam point of view, like only numerical problems, only derivations, only H.C. Verma book discussion, only IE Rodo problems. Many of the micro courses have been conducted by me. Many micro courses Shimon sir has conducted, Wazim sir has conducted. All the amazing teachers that you see on YouTube and who are not also there on YouTube are there. Amazing teachers. So guys, that's the best part about Vedantu Pro subscription, because you know, when you join a coaching in 12th standard, they never give you the chance to attend 11th standard topics, and that too, you know, as per your own schedule. So I feel this is a very good plus point. And remember guys, one more thing, whatever I teach today will also be available to you in the description box. There is a link for joining the Telegram group. So when you join the Telegram group, you not only get the PDF of today's session, but you also get regular updates, all the important announcements that we do. So do not forget to join the Telegram group. Let's get going. Now, the properties of a conductor regarding field. So we were talking about charges before this. Now let's talk about field aspect about the conductors. So guys, yes Sunil, don't worry, I'll tell you how much you have to pay towards the end, bacha. Yes, it's not much. It's almost 1/5 the cost you would usually pay to a regular coaching. 1/4 to 1/5 of the cost. Okay. So now the field inside a conductor is always zero. Very important property. So the field inside a conductor, that solid part which you see over here, will always have zero field. Why? Because no matter how the charges are. So guys, understand, this is irrespective of the charges and their location. Reason is, if the field is not zero, so think about it, if the field is not zero, then what will happen? The free charges will experience force, which is Q into E. The free charges will experience, so let's say there are electrons here, they will experience force because of the field. And once there is force, what will happen? They will start moving, and once these charges move, what will happen? There will be current inside the conductor. Now, who created this current? There is no source of energy. Understand that. If you have a charged ball, magically current can't start flowing inside it. You need an external source of energy like a battery, voltage difference, etc. So there was no battery, no energy source. How can there be current inside this conductor? Because if it was there, then I would carry these charged balls inside my pocket, and you know, I would charge my mobile phone at ease. So guys, understand, the field inside the solid part of a conductor has to be zero. Yes, that's the reason behind it. Correcto. Hello Neha, again late. Okay, cool. Let's get going to the next one. Okay, Mankiri Lafi, no problem. Okay, great, Jay Ajinkya. Glad to know all your waves on a string concepts were clear. Jay Ajinkya, I have also conducted a micro course on problem solving on waves. Just problem solving. There are beautiful questions which I have conducted. Watch that micro course as well. You will be really benefited from that micro course. In fact, all the chapters of 11th I have conducted a micro course for numerical problem solving. Okay. Next up, the field lines are always perpendicular to the surface. Now this is not just true for a spherical object, but this is also true for any oddly shaped conductor. So no matter how the conductor is, so even if you have a conductor like this, understand the field lines will always originate perpendicular to the surface. They might bend later on, that's okay, but wherever they originate, they will be perpendicular. So that is what is important. So they will always be perpendicular. Very, very important. So field lines are always perpendicular to the conductor. Please understand, they cannot be inside, because inside the field is zero. So they cannot penetrate inside a conductor, field is zero, only outside the conductor they can be present, and that too perpendicular, they will originate from the surface. That's the next property. Okay, no problem catch student, no problem, surely watch the replay. Okay, so is Gauss law applications very important? Yes, Nageli Mamta, it's very important, because even in February and March attempt there were so many questions on Gauss's law, and a lot of people did not study applications. So guys, understand, please understand this, you are not in a position to leave any chapter. This is the wrong approach. Please never think, should I leave this chapter, should I study this chapter, because you are right now in 12th standard. See, you are not a dropper, or you are not a student who is going to write the exam next month. If that was the scenario, I would have told you which chapters are important and not important. But before the preparation begins, you cannot set in your mind that, okay, I'm not going to study this. This is important. This is not so important. Lot of coaching institutes do that. They tell inside the class, this is not important, don't study. Oh, this is important, you study this. That is a wrong approach. How can you train a kid like that? Yeah, that is so unethical, I feel. Okay, so please never do that. Okay, so this is very important property. The field just outside the conductor is sigma by epsilon naught. Now this is something which was also done last lecture, if you remember. In my last session, last L2 session, you would have seen this formula, sigma by epsilon naught. Now people get confused. Sir, when to use sigma by 2 epsilon naught? When to use sigma by epsilon naught? I'll tell you guys, very easy to remember. See, if you have a sheet plate, okay, which is charged. So if you have a sheet or a plate, then understand the field will go both sides. It will get distributed into two sides, two parts. So that field will be sigma by 2 epsilon naught. Half of sigma by epsilon naught. Half sigma by epsilon naught here, half sigma by epsilon naught here. So that's what it is for a sheet. But when you have a conductor which is charged like this, example, when you have a conductor which is charged like this, for example, then understand the field lines originate only from here. They are not inside. Remember, inside the field is zero. They are only going on one side. So here the field will be just sigma by epsilon naught. There is no by 2. It's not divided into half. I hope this is clear. Nishi, we are completing 12th fully now because this is a long-term course. Pathfinder is a 12th standard course aiming for JEE 2022 aspirants. But in my flash series, I have covered all the 12th standard portion in crisp way, in a short manner. So I hope this is clear how to remember this. Okay. हर्ष राज शर्मा, आई थिंक तुम्हारे कंप्यूटर स्क्रीन में कुछ गड़बड़ है. एवरीबडी एल्स इज एबल टू सी माई हेयर ब्लैक. कभी कभी होता है दैट डार्क पॉइंट इज देयर इनसाइड दैट एलसीडी स्क्रीन. सो व्हाट हैपेंस, दैट डार्क पॉइंट नो दैट गोज टू ब्राउन, and that happens because of the liquid crystal displays. So that liquid gets accumulated below because of gravity. So what you do is take your laptop, turn it upside down. So you know that liquid will flow ulta and it will make your screen proper, so that liquid will go on the top. So just make it ulta and turn it back. So hopefully that will resolve the problem. एक बार देख लो. Okay, just try it out. Yeah. So that's because of gravity and all that. Okay, cool. Yes. So okay, let's get going guys to the next question. Okay, so remember this property. Now the second property. So the second property guys is this one. Sigma is inversely proportional to the radius of curvature. So wherever it is sharp, remember this. So whenever it is sharp, okay, a sharp edge like there, so sigma is also more. Wherever it is blunt, like this edge, sigma, the charge density, is also less. And there is a very interesting picture to show you this. Very interesting picture to show you this. Let's see what is that. Look at this beautiful woman. Okay, do you see something crazy about her? Is her hairstyle better than mine, or my hairstyle is better? You can tell me. All right, Aisha Babar. All right, come on, think. Okay, it is looking. Acha, Sunil, it is still looking brownish. Sunil. Acha. Do one thing. Turn it more ulta and just hit your laptop little bit so that liquid crystals will move little bit more down. against the gravity and then again turn it. See if it works. She's upside down. No, she's not upside down. So I'll tell you what it is. So her hair are standing. I don't know whether you can see it, but her hair are standing like this. Now that is happening because, oh, mine is better. Thank you, Minion Aarti. Okay, Sunil, I'll send. Oh, okay, Sunil, no problem. I'll have a look at your screen. Sure. Okay, so the cloud over here, the cloud, not your iCloud or Amazon cloud and all that. The cloud is charged. The cloud is charged and it is about to discharge a lightning. It's about to discharge a lightning. Now, because of that charge, there is field. And understand, because this is a sharp edge. Can you see that? There is a sharp edge over here. The field lines are very strong over here. The field lines are converging. They start from here and go till the cloud. Very sharp. The charges are accumulated on the tip of her hair. On the tip of her hair. You can see that. Okay. The charges want to go. They want to fly off because they're waiting for that discharge from the cloud. So that's why our hair are standing. And if this ever happens to you, all right, and you see your hair standing, somebody is clicking photograph. So what should you do, guys? Yes, what should you do, guys? Okay, Neha does not like my hair. Oh, why Neha? Okay, he's going to get a shock, surely. Please run, guys. If this happens, please run. Yeah, you are not this mega cat out here who is going to grab all that power from the thunder and lightning. So please run from that place. You should immediately run. Please do that. Okay. Yes, thank you, Venkata. Is that clear, sir? This is rain? No, this is thunderstorm. This is lightning. Yes, short hair. Correct. And by the way, this girl did not survive this. Let me tell you that. Okay. Oh, okay. Cool. So let's get going. Oh, somebody has shaved their head. Okay, good. But then how will you know? So carry your friend along every time who has a lot of hair and tell him he's like a lightning detector. So carry your friend with a lot of hair. Okay, and he or she will be your lightning detector. Okay, so let's get going to the next question coming up on your screen. For the isolated charged conductor, the figure of the figure, the electric fields at different points A, B, D. Remember, A, B, D are on the surface. A, C, D are on the surface. B is inside. So understand this. B is inside. So B is inside, whereas all these other things like A, C and D, where are they? They are on the surface. Okay, so they are on the surface. So guys, think about it. I know this is not so clear, but just think about it and what do you think the correct answer should be? Oh, is it Venkata? Oh, I thought it reduced my age. No, Tribak. Look at this. Everybody is asking the same question. Sir, have you colored your hair? What do you think, Tribak? Yes, I have. Okay. So guys, yes, what is the answer? Some of you are saying C, some of you are saying B. Is that correct? Which one is correct? Oh, Brajesh, yes, I do remember you from my Drishi B batch, for sure. Okay, thank you, Shivani Gautam. All right. Yes, charge density is inversely proportional to radius of curvature. Correct. So, yeah. So, which has more radius of curvature? Look at that. So, guys, this is the sharpest. This is the sharpest edge D. Then this point B, all right, is inside. Please keep that in mind. This A has some decent radius of curvature. This C is on the blunt side of that surface. So guys, remember surface charge density is inversely proportional to radius and sigma is directly proportional to field. So field is inversely proportional to radius of curvature. So wherever it is sharp, the field is more. So where is the sharpest edge? D. So that's why it will be highest there. Okay, sorry, not there. It will be highest here. Then it will come A, because A will have decent amount of radius of curvature, and then comes C. But remember, B is 0 because it is inside. So because B is inside, remember inside a conductor the field is always 0. I hope this is clear. Yeah, that's the answer. So D is the sharpest. So radius is very small. So field is very large. So remember, when you have the sharp edge, the radius is very small. When you have a blunt edge, radius is very large, field is small. That's how this works. Yeah, correcto. Yes, Harshraj, your laptop is all right. Okay, so I wonder who was that guy who was trying to turn it upside down. Somebody sent me a screenshot also. Okay, next question, guys, coming up on your screen. A point positive charge is brought near an isolated conducting sphere. A point charge is brought near an isolated conducting sphere. The electric field is best represented by which of the following diagrams? The electric field is represented by which of the following diagrams? Come on, think about it. Is it figure 1? Is it figure 2? Is it figure 3? Or is it figure 4? Which diagram best represents the field due to a point charge and a conducting sphere? Come on, think about it. Use all the properties. Anvesh, I'm doing that in Killer 5. I'll be doing that, Anvesh. Yes, I'll be doing Killer 5 series. That's for JEE Advanced only. Okay. Thank you, Trinbach. Yo. Okay. Whether my age is 34, maybe, may not be, I don't know. Okay. So guys, the answer is actually C, A, because if you notice this in the first diagram, the field lines are perpendicular everywhere and the field lines originate at a positive charge. They originate at a positive charge. Inside, you can see everywhere the field is perpendicular. Inside the field is 0, and again over here the field lines are perpendicular. So this is perfect. What about this? Look at that, the field lines are not perpendicular. I hope you can see that. There is an obtuse angle over here. Again, the angles are not 90 degrees. So it is not correct. How about this? Same problem. You can see the field lines are not perpendicular. Alright, because it is originating from here. Obviously the field lines won't intersect perpendicularly. And then you might be confused between this and this diagram. So I'll tell you what is the difference between this diagram and that diagram? Can you see that? What is the difference between this diagram and that diagram? The first and the second. There is a very interesting thing that is happening. See, understand, here the field lines are terminating. They are terminating, that means there is a negative charge here. Correct? So if there is a negative charge, there must be an equal amount of positive charge on the other side, because it was given that it is an isolated conductor. Alright, it is an isolated sphere or a conductor. That means if it is positive on right side, how can field lines end over there? So field lines should originate from the positive charge. So this part is wrong. So they are terminating. They are terminating over here. So how can field lines terminate on a positive charge? Hence this diagram is wrong. This was wrong, and this was wrong, and this was correct. Is that now clear? So gaming adda, what has happened? Basically, we have used few properties like field should be perpendicular to the conductor. So you can see over here the field lines are perpendicular. Field inside is 0. That is also correct. They are originating from positive charge, ending at a negative charge, because there will be a negative induced charge. And an equal amount of positive charge will be there on the other side. So you can see the field lines are originating over there. You will see at least one of these laws will be broken in the other three diagrams. I hope this is clear. So Arnav, this is JEE Mains and Advanced both. Remember, this is a long-term batch. So in long-term batches, you don't have something like JEE Mains batch and JEE Advanced batch. There is a JEE Mains plus Advanced. Only if you clear Mains, you will write Advanced. Only if you understand the Mains concept, can you write Advanced concepts. Also, remember the theory for Mains and Advanced is almost similar. So that's why the batches are also same. Okay. So guys, let's go to the next question. Yep. Very smart Venkatakrishnan. Okay, so here it is. Next question. A point charge plus Q is placed at a distance d from an isolated conducting plane. A point charge Q is placed at a distance of d from an isolated conducting plane. The field at a point P on the other side of the plane. The field at a point P on the other side of the plane. In case you are finding it hard to visualize, let me just draw a diagram. This is a conducting plane. Okay, this is placed at a distance d from a conducting plane. So this one is nothing but this, and there is a point charge plus Q. Okay, it is at a distance d from the plane. Okay, now think, how will the field at a point P on the other side, how will the field at a point P on the other side of the plane look like? Come on, think about it. Oh, did I show the answer? Is it for this one? Really? I'm not sure. Okay, come on, think. Yep. Oh, for the previous one, yes. I showed the answer, correct. Okay, come on guys, some of you are saying B. Come on my warriors. Come on, do not let the Josh die down. And guys, in case you have forgotten to hit the subscribe button or hit the like button, please do it now. Show your love and support. I know many of you regularly love our videos, and if you're a regular user, you would have already subscribed. But in case you have forgotten, please do not forget to do that. Thank you, Kumra Guru. All right. अच्छा, समझ में नहीं आ रहा क्या करना है? I'll tell you what to do. Because of this positive charge, what will happen? There will be more negative charges here. There will be negative charges over here. Correct? Something like this. There will be negative charges over here. Now, where would these negative charges on this plate come from? Remember, this is a conducting plane. This is a conducting plane. Where do you think these negative charges will come from on the right side? These negative induced charges would have traveled from the left side to the right side. So hence, there will be positive charges over here. Correct? There will be positive charges over here. Yes, Mohammad Furqan, you can still watch for need. Theory is the same. Correct? Induction. Remember, this was a neutral plate. So the negative charges will move from the left side to the right side. But on the right side, they will accumulate towards the positive charge. So now, because of these positive charges, what will be the field? The field will be like this. Correct? The field will be like this. What kind of field is this? Isn't this a uniform field? And isn't the field always perpendicular? Remember, the field is always perpendicular to the conducting surface. So check which of the following options are correct. I think directed perpendicular to the plane and away from the plane. You can see that. B is not correct. See, directed perpendicular to the plane, but towards the plane. That means towards the right side. Guys, this is a positive charge. How can it be directed towards that side? So it should be away. So this word towards is wrong. Directed radially? No, this is not radially away. This is perpendicular. So that word radially is wrong. Directed radially, again, this word radially is wrong. I hope this is clear. So only A is correct. I hope Janvi Gowda, you understood why C is not correct. Yes. Oh, yes, definitely, Ankit. If you do JEE Advanced, NEET to will be for sure, pakka clear. That's the answer, guys. A. Understood? Very clear. Very good. Okay. Negative charge will induce electric field towards the plate. Yes, Aditya. So basically, see, understand this problem. See, this is the plate. Okay. This is the positive charge. Correct. So that negative charge will be here. Correct. That negative charge will be here. Okay. Now understand these negative charges have left from the left side and move towards the right side. So there is a positive charge here. Remember, here inside the field should be 0. So there is no contact between them. Inside there is a complete isolation because this is a part of a conductor. So the field inside will be 0. Keep this in mind. So the positive charges will no way know what is there on the right side. The negative charges will no way know what is there on the left side because there is an isolation, because there is a cut in the field lines. The field lines get interrupted in between. They originate from here, all right? But over here, they are there, but inside they are not there. I hope this is clear. Understood? Yep. So that is very important. Let's go to the next few properties. And now we are going to talk about potential. Very important. Now this is, understand guys, this lecture is very important for the next class. That would be our last class on Gauss's law. And after that last class on Gauss's law, we are also going to have a Menti quiz. So better start preparing for Gauss's law because you're going to have a Menti quiz next week after the 4th lecture. Okay, so be ready guys. Now the entire solid surface of a conductor is equipotential. Very important. So no matter which 2 points you take, they are always going to show 0 volts. Now equipotential means the potential difference is 0. So this is nothing but potential. The potential difference is 0. Now there is a simple reason for that. The reason for that is the field inside a conductor is 0. Remember this, field inside a conductor is always 0. And I hope you also remember field is delta V by delta R with that minus sign, dV by dr. I have told you about this many times the field is negative delta V by delta R. So if E is 0, what will happen? Delta V also will be 0. Hence the potential difference is also 0. I hope this is clear. Thank you, Pinky, so much. Okay, Janvi. Glad. Okay. So we Enthuse FC, the answer for the yesterday's homework is already uploaded on our Telegram group. So on the Telegram group, you can download the PDF and scroll down to the last slide. So when you go to the last slide, you will see the answer. Okay, just see that. Okay. Great, great. So the potential difference is 0. All points are at the same potential. Next important point. Next important point is that if you have a conductor, the equipotential lines will surround them as if it has taken the shape of that conductor, and they will form concentric figures. So imagine this. You have a conductor which is like this, some weird shape like a donut or a kidney. So this is our conductor. Okay, so this is our conductor. So what will happen is the field lines will be always perpendicular, correct? The field lines will always be perpendicular. It will be something like this, maybe. Okay, it will be like this, it will be like this, it will be like that. These are the field lines. How will the equipotential lines look like? Equipotential lines always have to be perpendicular to the field lines. Remember, equipotential lines and field lines are always perpendicular. So they will actually take the shape of that conductor as if you are enlarging it. So these red lines are equipotential lines. Any point on that red line will have the same potential, but those 2 points on 2 different red lines will have a potential difference. I hope this is clear. Understood, everyone? All my warriors? Have you understood? So very important, as you take a conductor, the potential lines surround that conductor and take the same shape, and they grow bigger and bigger as if somebody is zooming onto it. Okay, zoom out onto that. Okay, great Neha, great Frederick. Thank you, Shivani. All right, Sakshi. Yes, KVPY SX also, Sakshi, because KVPY SX is 12th standard portion. So we are also going to launch KVPY SX series when the KVPY exam comes close by. Okay, so towards the end of the year. But for now, we need to complete the 12th standard portion. That's our first priority. A lot of people join a KVPY class. That is waste, guys. Understand, you don't need it right now. First complete the portion, then you can clear all the Olympiads, all the scholarship tests, etc. Priority is to complete the portion first. Do not get excited and look at others. Oh, he has joined KVPY class. Oh my God, he has started studying for NSCP. See where you are. Maybe he completed the 12th portion last year only. So that's why I want everyone, please complete the portions first. Okay, next question. Next property. When two conductors are connected, the charges flow till potentials are equal. Till potentials are equal. Yes, is this an experimental property? No, this is basically going to come from, like, basic properties, Aditya, like field and potential have to be perpendicular. All right. So using that you get it, because field lines are perpendicular to surface. Potential is perpendicular to field. So potential is parallel to the surface. That's what happens. Okay. Yes, Vulcan, I did. Okay. Oh my God, Shivani, you are a dropper. Okay, don't worry. We are going to work extra hard for you, and there are lots of series like Zero to Hero mock tests coming up for all of you. So whenever two conductors are connected, what will happen? So let's say there was some charge here. These charges will flow, all right, till not the charges are equal, till the potentials are equal. Keep this in mind. Very important. And let's say the old charges were Q1 and Q2. These were the old charges. And these were the new charges, small q1 and small q2. Guess what is the relationship between them? Hi baby, welcome aboard. So guys, think about it. What is the relationship between the old charges and the new charges? Very simple relationship. Charge conservation. Q1 plus Q2. The old charge will be equal to the new charge. The total new charge will be the total old charge. This is nothing but, the charge conservation. So very important. You will need, two equations. One is conserve the charge and equate the potentials to solve the problem. Yep, correct. Now, this behaves like one single body. Now, let me show you an example just to get a feel, get a hang of this. Let's get a hang of this. Just imagine there is a charge Q over here. okay, and there is no charge over here, or let's just assume something like, I don't know, maybe there is 4q charge over here. There is 4q charge over here. This is the old charge. Example. So now, what is the total initial charge? What is the total initial charge, guys? Think about it. What is the total initial charge? What is the total initial charge? Isn't it 5q? Isn't it 5q? Think about it. Okay, so yes, it will be 5q. Very good. Yep, it will be 5q. Correct. Now, I want you to think, if I talk about the new charges, think if this sphere has q, that sphere will have 5q minus q, because the total charge should still be 5q. So if this has q, that has 5q minus q. Correct? Now let's say the radii are given. Let's say this is r, and let's say this is 2r, guys. Example, this is r, that is 2r. So when the charges get distributed, the potentials are equal. So potential of the left sphere will be potential of the right sphere. The potential of the left sphere should be equal to the potential of the right sphere. Correct? Now think, guys, what is the potential of this sphere? What is the potential formula? I gave you yesterday, a formula for field and potential. You have also learned this in gravity. This is like a charged sphere, all right, having q charge. The potential anywhere, be it at the center, all right, so, or be it here or there, it will be same. And how much will it be? It will be q divided by radius, which is r. Every point will have the same potential, kq by r square, nahi pinky, r. Be careful, r square is for field. Potential will have only r. Be careful, that one r is not there. And over here, the potential of the other sphere, what is the value? The potential of the other sphere will be k into 5q minus q divided by 2r, because the radius is 2r, and just equate the two. Just equate the two. So guys, see what will happen. K will get cancelled, r and r will get cancelled. So rearrange the equation. So 2 will come here. So 2q, okay, so 2q, okay, will be equal to 5q minus small q, correct? So rearrange it further, so it will become 3q is equal to 5q, so therefore small q will be 5/3 of q. So that is the answer. So the left sphere has 5q by 3 as the charge, and the right sphere will have 5q minus q as the charge, as it is. Done, done, done. Okay, now Aditya, understand, should we take potential at the surface or at the center? Remember, the potential here, here, here is the same. All of them will have the same potential because they are part of the same sphere. Usually it's easy to understand if you look at it like this. This q charge will distribute like that. This q charge will distribute like that. Okay, now when you are at the center, all the charges are equidistant. What is the distance? R, right? So all the charges are at the same distance, and potential is a scalar quantity. Don't cancel it like vectors. So that's why the potential at the center can be easily calculated as kq by r. Done, done, done. I hope this is clear. Yes, because it's a conductor. If it was not a conductor, charges won't even flow. Remember, this entire lecture is properties of conductor. For insulators, nothing will happen. I hope this is clear. Done? No, potential won't be 0, Pranay. Field will be 0. Potential will be same everywhere, in fact, because each positive charge will give rise to potential. So potential will be same, field will be 0. Field are vector quantities, they will cancel out each other. Potentials will add, they are scalars. Is this question clear? Is this concept clear? Are all my warriors understanding it? Let me know by writing clear O, understood O, amazing O in the chat box. Let's get going to the next property. When a conductor is connected to earth, then the potential becomes 0. This is very important. Now this is also used in many appliances. You have something called as the earthing. Now earthing means whenever you touch something which you should not touch, like the blade of a fan or the metallic casing of a device, maybe a washing machine or something, and there is some leakage. So understand, if let's say this is a device and this is our Pandu, okay, and he nicely touches it and there is some leakage. There is some leakage, that wire is touching that metallic casing. Now, what will happen is that if there is no thing like earthing, this current will flow through Pandu's hand, through Pandu's body, inside the earth. Because remember, earth has low or basically zero potential. So all the charges would love to flow or till it is all drained out. Now, because of this, Pandu will encounter shock because current is flowing through his body. Now, you don't want Pandu to get shocked. So what you do, you create another wire touching the body, and that is inserted inside the earth. That is inserted inside the earth. This is a symbol for earthing. Now, because the current has leaked, as soon as it touches the metallic body, it has two options. Option 1, to go from here. This is option 1. Second option, to go from here. This is option number 2. Now, which option do you think the current will prefer? To go via Pandu or to go via this earthing wire? The answer is, it will prefer to go via the earthing wire because Pandu's body has some resistance. This earthing wire is made of a very good conductor, so it offers very less resistance. So all the current gets drained out to the earth and nothing goes through Pandu's body. I hope this is clear. Is this understood? Yep. Is this clear, everyone? So that's what happens. Correct. So whenever you connect something to earth, the potential becomes zero. Okay, let's see these problems. Yes, the least resistance path, correct. For the isolated charge conductor, which points have more potential, same potential, greater potential, less potential? Come on, think, compare. A, B, C, D are the points. Who is Pandu? You will understand it, Venkat, very soon. Yes, Khushbu Pach Gaya Pandu, cute lover boy, welcome aboard. So guys, which point has more potential, less potential? Come on, think about it, all my warriors. Sir, is HCV enough for all chapters? No, Sukhdev, you need to do previous year questions and Tattva module which Vedantu gives you. So when you are in the Pro subscription, we give you a special booklet which you can scan for all the solutions. You get all the assignments, easy, medium, hard level questions, theory, derivations, everything is there in that. So all this you need. Okay, is this class 12th? Yes, Venkat, like you can see, class 12th Pathfinder series long-term batch. Yes, it should be equal at all the points. Correct. Beautiful. It is equal at all the points. I just told you this property. The potential is same everywhere. Yep, it is going to be same everywhere. Beautiful, guys. Next, a spherical equipotential surface is not possible for which of the following? A spherical equipotential surface is not possible for which of the following diagrams, for which following situation? Think about it. Cute little boy, this is Gauss's law, bacha. Like you can see in the description box below. And we are in the third session. There is one more session to go. Okay. A, B, C or D. Come on. All my warriors, think. Which of the following scenarios will not give you a spherical surface? Guys, if you have a point charge, then you have a dipole. Oops, where is it? You have a dipole inside uniformly charged sphere. Inside uniformly charged sphere. And then inside a spherical capacitor. Doesn't matter what a capacitor is. Okay, it has to be a sphere. So guys, in all these cases, okay, the equipotential lines will be circular, even in the case of point charges. But in the case of a dipole, please understand, it will be something like this. I hope you remember that diagram. It is something like that. So it is not spherical. So the answer is B. Very good. That's the answer. Yep. B for a dipole. Excellent. Now, let's see if we can answer this really quickly. There is a conductor and it is earthed. Okay, there was a charge Q given to it. The moment you connect it to the earth, what do you think will be the distribution of the charges? Come on, think about it. What will be the distribution of the charges the moment you connect a sphere, a shell, which has been given a charge Q on it? How will the charge distribution look like? What will the charges be? Come on, type it out in the chat box. Cute lover by my name is Shreyas. My name is Anthony Gonzalez. मैं दुनिया में अकेला हूँ. घर भी है खाली, दिल भी है खाली. Okay, come on, think. What should be the answer? Think. What should be the answer? You connect it to the ground. Guys, I'll tell you what. Imagine there are two surfaces. This is the first surface and this is the second surface. Two surfaces are there, the inner shell surface and the outer shell surface. So think about it. What will happen? What will happen? See, if you take a Gaussian surface through the thickness of the conductor, this is a Gaussian surface through the thickness, yes, through the thickness of the conductor. So think about it. What will happen? See, this is that conductor. I'll just show that. This is the thickness of the conductor. Your Gaussian surface. What is the conductor? What is the field value, guys? Field inside the conductor is always 0, right? Field inside the conductor is always 0. So guys, think about it. If I use Gauss's law, okay, which says net flux is equal to enclosed charge by epsilon naught. What is the net flux cutting through that black sphere, cutting through that Gaussian surface? What is the net flux value? Isn't it 0? Because there is no field. If there is no field, what will be the flux? Nothing will pierce through that Gaussian surface. So shouldn't inside charge be 0? So that means Q on the first surface, because remember the first surface is inside, it's inside the Gaussian surface. It's inside the Gaussian surface. So hence the inside charge should be 0. Correct? Beautiful. Now if the potential of the shell should be 0, obviously even this second charge should be 0. Because if there is any charge, then there will be potential on the sphere. So hence both the charges will be 0 and that's the final answer. I hope this is clear. I hope this is fine. Understood? So we first proved that the inside charge is 0 and then we proved the outside charge is 0. Because if any one of those charges are there, then there will be potential inside that sphere. But remember, you are connecting it to Earth, so the potential must be 0. So hence the answer is 0. Now I am giving you a homework question. Please try and post the answers in the comment section below. As soon as the video ends, solve this question and post it below. You will also get the question in the session PDF, which you can download it from the Telegram group. Now, since it's a year of online learning, I know many of you are interested in joining the Vedantu Pro subscription. Some of you are asking, when is the batch starting? So the batch is starting on 3rd May. So Abhijit, Wazim sir's batch and Shimon sir's batches are starting in the first week of May. So please understand, it's first come, first serve. So, you will be allotted batches. You can change it later on, but it's better to start early and not miss classes, because then you will lose the flow. Okay, and I'm also going to teach in lots of micro courses for 11th as well as 12th standard. So guys, please go ahead and check out all the details of the pro subscription, which is there in the description box below. Because there is a reason why I tell you about the pro subscription. Reason is our results. Look at the results, guys. I mean, in JEE Mains 2, there were 686 students just from Vedantu alone who got 90 percentile above. Also, not just that, 1 in 2 Vedantu students have already qualified for JEE Advanced. And not just that, 1 in 10 Vedantu students have scored more than 95 percentile in JEE Mains second attempt. And these results are going to improve in the third attempt. So guys, imagine if crash courses and the pro subscription can produce amazing results like this. People who joined later on also got really amazing ranks. So imagine what 1 year of hard work and our effort will do to you. So guys, that's why I'm telling you, you are going to get the long-term batches, plus there will be English batch separate. Lots of batches are in English only. Let me tell you that you will get tests series as a part of it, assignments as a part of it after every class, and lots of questions, plus the hard copy and the soft copy of Vedantu booklet, which is called as Tattva material, which is exclusive material of Vedantu, with lots of questions, easy to hard, previous years, concept based, theory, derivations, formulas, all of that in that. and obviously the best teachers, plus you get the doubt solving facility in this. So I will be coming live tomorrow again in the morning. Okay, no problem, Neha, you can watch the replay again. Okay, so thank you, Vikram. I'm your motivation. So guys, I would love to see all of you. I would love to see all of you, not just on YouTube, but also in the pro batches, which are launching very soon. Some of them have already started. Already Gauss's law is over. Current electricity is midway. So guys, do not delay this. There are 3 versions if you see in the link, which is there in the description box. The light version has everything except for the doubt solving facility. So if you want the doubt solving facility on the mobile app, then you need to go for the classic version where you can interact, chat with our doubt experts, send screenshots from morning till night. And if you want a dedicated personal mentor, then you have the plus version. And all of this, you can see the price for the light version for the entire year is 35,999. I mean, look at even the classic version, guys, it's 45,899. It's definitely 5 to 6 times lesser than your regular coaching fees, which you are going to give in case you join an offline coaching institutes. And they are fooling people by telling that we'll give you online classes. And their classes are on Zoom, on Google Meet, and they are just makeshift arrangements. And they're charging, offline fees for online classes. A lot of institutes are doing that. Guys, we are not charging that much. Why should you pay an offline fee, that also which is expensive? Education should be as minimal as possible. Education cost should be as minimal as possible, and that's what we give you over here. These are just bare minimum just to meet our livelihoods. Trust me on that. Okay, these are just bare minimum costs. So use the coupon code SHHPRO so that you can get 10% off on the complete package. SHHPRO, that's the coupon code. Thank you guys for tuning in. I'm sorry I was low on energy because I'm not feeling well. I'm running high, not very high, but decently, moderately high on fever. And so I'm trying to gather all my strength and coming over here just to see all your love and support. So please do not forget to hit the like button. And if you're new over here, please hit the subscribe button down there. Thank you guys very much. Thank you Khushbu, Chandran, Priyanka, Frederick, Enthuse FC, Losha, Neha, Vikram, Cute Lover Boy, Sinu. Thank you Aditya. Take care. Sir, in JEE Advanced 2018 paper, the question was asked to find the radius of spherical equipotential surface of a dipole placed at the origin. Question asked to find. Don't worry Aditya, we'll take it up in the Killer 5 series. Okay, don't worry, we'll take it up. Okay, thank you guys for all the love and support. Bye bye. Take care.